The Big Bang was a straightforward hypothesis that dates all the way back to the 1920s, that because the universe is expanding and cooling right now, it was once hotter and denser. It is commonly regarded as the hypothesis explaining the creation of our universe, since it has produced a number of accurate predictions that no other theory can match. The Big Bang, however, is much more than that and is no longer the very beginning of everything at the same time. Explore these Big Bang-related facts that you might not be aware of. Presented by AWZ. Don't forget to subscribe this channel and click the bell icon for more other interesting videos. The Big Bang is the most likely response you'll get if you ask a scientist how the universe came to be. The enormous expanse of empty space that separates our universe's stars, galaxies, and cosmic web of large-scale structure from one another was not always that way, and it hasn't been this way forever. Instead, the universe evolved into its current condition through expansion and cooling from a hot, homogeneous, dense, matter and radiation-filled state in which there were no galaxies, stars, or even atoms. Approximately 13.8 billion years ago, nothing was the way it is today in its current form. Furthermore, only in the last 100 years has all of that history been fully understood. Even yet, there are a number of facts about it that most people, including many experts, don't entirely understand. When it was first suggested to Einstein as a possibility, he immediately rejected it out of hand. In 1915, Einstein's general theory of relativity, which replaced Newton's theory of gravity, was proposed. It predicted starlight bending by mass, which was proven in 1919, and it anticipated the existence of gravitational waves, which was only recently proved. Newton's theory was unable to predict the orbital motion of Mercury with such accuracy. But it also stated that a universe that was static or constant across time and full of substance would be unstable. Georges Lemaitre, a priest and scientist from Belgium, proposed the idea in 1927 that the space-time fabric of the universe might be very large and expanding, having evolved from a smaller, denser, more uniform state in the past. Einstein responded to him by saying, "Your calculations are correct, but your physics is abominable." It became a serious theory after Hubble discovered that the universe is expanding. Even before Einstein, many scientists believed that spiral nebulae in the sky were faraway galaxies on their own, but Edwin Hubble's study in the 1920s proved that this was not only accurate, but also that a galaxy's speed of separation from us increased with distance. Hubble's law, which describes the expansion of the universe, leads to a fairly simple explanation that is in line with the Big Bang theory. If the universe is expanding now, it was previously smaller and denser. Although the concept has existed since 1922, it was widely disregarded for many years. The theory for it was developed by Soviet physicist Alexander Friedmann in 1922, after Einstein had objected to it. Einstein similarly disregarded Lemaitre's 1927 work, and even after Hubble's work in 1929, the notion that the universe used to be smaller, denser, and more uniform was still considered a far-fetched theory. The best evidence for the expanding universe came from observations made by Hubble, but he did not openly endorse the hypothesis until much later. Lemaitre contributed the crucial notion that the redshift of galaxies could be accounted for by this expansion of space, and that there must have been a moment of creation at the start, which was for decades referred to as either the primal atom or the cosmic egg. When the theory delivered a shocking series of predictions in the 1940s, it gained real traction. Lemaitre's theories captured the imagination of an American physicist named George Gamow, who came to understand that if the universe was expanding at the moment, its wavelength would be lengthening with time, indicating that the universe was cooling. It must have been hotter in the past if the weather is cooling off today. He realized, extrapolating backward, that there was a time when the temperature was too high for neutral atoms to form, and that there had been a time before that when the temperature was too high for even atomic nuclei to form. The occurrence of a primeval fireball, or a cosmic background of cold radiation just a few degrees above absolute zero, indicates that when the universe expanded and cooled, it must have first generated the light elements, followed by neutral atoms. The most vocal opponent of the hypothesis, Fred Hoyle, is also the one who gave it the name Big Bang. The steady-state theory of the universe, which makes different predictions, was the dominant theory of the universe in the 1940s, 1950s, and into the 1960s because nuclear physics supported the idea that the vast majority of atoms originated from dying stars rather than from this early, hot, dense state. In a 1949 radio interview with the BBC, Hoyle introduced the phrase by saying, "One of these ideas was that the universe began its existence a finite amount of time ago in a single, violent explosion, and that the current expansion is a remnant of that explosion's ferocity." Even before further analysis revealed that the Big Bang theory results in significant issues, it seemed to me to be unsatisfactory. At first, it was believed that the glow from the Big Bang, discovered in 1964, came from bird droppings. Scientists Arno Penzias and Bob Wilson made the discovery of a consistent radio signal originating simultaneously from every location in the sky in 1964 while working at the Holmdel Horn antenna at Bell Labs. They attempted to calibrate this noise away, not comprehending that it was actually the glow left behind from the Big Bang. When that failed, they climbed inside the antenna and found pigeon nests there. They removed the pigeons' nests and waste from that area, yet the signal persisted. The Big Bang model was confirmed as the scientific explanation for the beginning of the universe when it was realized that the finding was in fact Gamow's prediction. Additionally, it makes Penzias and Wilson the only Nobel laureates to clean up animal waste as part of their research that merited the award. The confirmation of the Big Bang provides us with a clear timeline for how the universe's rocky planets, galaxies, and stars came into being. It would take time for gravitation to draw items together into gravitationally collapsed structures if the universe had initially been hot, dense, expanding, and uniform. Additionally, the universe would cool and eventually give rise to atomic nuclei and neutral atoms. The formation of the first stars would take between 50 and 100 million years, that of the first galaxies between 150 and 250 million years, that of Milky Way-sized galaxies perhaps billions of years, and that of the first rocky planets, after many generations of stars had lived, consumed all of their fuel, and perished in devastating supernova explosions. The fact that we are witnessing the universe today, 13.8 billion years after the Big Bang, may not be a coincidence. It's possible that the universe needed this long, or nearly so, to ripen sufficiently for sentient life to exist. We can determine how uniformly fluctuating the cosmic microwave background is by looking at how it was before the Big Bang. The oscillations illustrated here are just about 100 microkelvin in magnitude, despite the fact that the cosmic microwave background is only 2.725 K now. However, the fluctuations are what give origin to all the structure, stars, galaxies, etc., that we observe in the universe today. This is demonstrated by the fact that the remnant glow from the Big Bang had small non-uniformities of a particular magnitude at that early time. The Big Bang itself no longer essentially denotes the beginning of time. It's tempting to go as far back as a singularity by extrapolating this hot, dense expanding condition as Lemaitre did almost a century ago. However, a number of discoveries, including variations in the primordial fireball, tell us that there existed an earlier stage in which the entire universe's energy was contained in space itself, and that space grew at an exponential rate. We're still looking into the specifics of the cosmic inflation that occurred during this time period. Science continues to go more and further, with no apparent end in sight. And the way the universe started does not necessarily indicate how it will finish. Finally, the Big Bang tells us that there was a competition between the initial expansion, which sought to tear everything apart, and gravity, which sought to recollapse the expanding universe. But without understanding the composition of the entire universe, we cannot infer the future from the Big Bang alone. We now know that the most distant galaxies will continue to accelerate as they recede from us due to the existence of dark energy, which was first discovered in 1998. Our fate in a dark energy universe is chilly, lonely, and empty, but it might have been very different if the universe had been created with a little bit more matter or radiation than it does now. This is all for today. Don't forget to like the video and subscribe our channel. Stay tuned with AWZ.